Here's example 3 with using reference triangles to evaluate trig functions. So here we're given secant of theta is negative 8 over 7 and pi is less than theta is less than 3 pi over 2. Okay, so we want to evaluate basically the other 5 trig functions of theta. Okay, cosine, sine, tangent, cosecant, and cotangent. So, alright, now we're just going to approach this like we did with example 2. So it's only just a tiny little bit more complicated because in example 2 we were directly given what quadrant theta is in. Okay, so here we have to do just a tiny bit of work to figure it out. So what we can do first is draw a picture and see, okay, I know theta is between pi and 3 pi over 2, so where does that put me? Well, let's draw a smaller picture down here and then we'll erase that. So this will just be our rough sketch picture. So x-axis, y-axis. An angle of pi, where does an angle of pi put me? Remember, here's a 0 right here, right? So pi puts me around here. So here's pi, okay? What about 3 pi over 2? 3 pi over 2 puts me all the way down here, okay? So here's pi, here's 3 pi over 2. So if theta is between pi and 3 pi over 2, theta is between this guy and this guy. So theta's got to be somewhere in here, which means theta is in quadrant 3. Okay. So if theta is between pi and 3 pi over 2, then that means that theta is in quadrant 3. Okay. Theta is in quadrant 3. Okay. Now again, just like in example 2, what we want to do is say, okay, since theta is in quadrant 3, which of these guys are positive, which of them are negative? All right. And actually, we don't really have to even say that for all of them. We only have to say that for cosine, sine, and tangent, not even all 3 of those. But just to be consistent and thorough, and just to get extra practice with that kind of thing, let's talk about all of them. So anyway, since theta is in quadrant 3, cosine of theta is negative, right? So we talked a lot about that in earlier videos. Sine of theta is also negative. Well, since both of these guys are negative, then tangent of theta must be positive. Okay. What about well, secant of theta we were given, okay, so we already know that's negative, we don't have to write that down. What about the cosecant of theta? Well, since the sine of theta is negative, the cosecant of theta is also negative, okay. So they're either positive, they're either both positive or both negative, right, sine and cosecant. And then lastly, the cotangent of theta. Well, since the tangent of theta is positive, the cotangent of theta is also positive. Okay? So again, why are we doing that? Because it's going to make it a little bit easier on us later, okay, so we're not going to be confused as to what's positive, what's negative. Just writing this off to the side helps us out later on. And again, we know these are true because we know theta is in quadrant 3, and we talked about in an earlier video which trig functions are positive and negative in which quadrants. Anyway, now let's go ahead and draw our real picture here. So theta is in quadrant 3, so let's put our focus on quadrant 3. Okay, so remember quadrant 1, 2, 3, 4. So we want to focus on quadrant 3 here. So we're dealing with angles in standard position. So theta has vertex at the origin, initial side over here. We don't care about that though. We just care that the terminal side is in quadrant 3. Okay, so remember when we say theta is in quadrant 3, we really mean the terminal side of theta. That's all we care about. So here is our angle theta. Okay. And remember, we talked about it in examples 1 and 2. When you deal with reference triangles, okay, we're talking about reference triangles. That's what we use to do problems like this, what we can use anyway. Always go to the x-axis. So I'm going to pick a point here, any point. It doesn't really matter where. Just pick one over here so I have enough room to work with. Then I'm going to drop or maybe raise, I don't know, a perpendicular to the x-axis. Okay. Always go to the x-axis, never go to the y-axis. All right, and then I'm going to fill in this side of the triangle. So now I have a triangle here that I'm working with, right? So now let's zoom in on this guy here. Okay, really, we're just going to approach the rest of this like we did in example 2. The only difference now is our reference triangle's in quadrant 3, but the only thing that's really going to affect is the positivity and negativity, which we've already kind of established, or we already kind of figured these out off to the side. So from here on out, it's really not terribly different from example 2. Okay, so what are we given? We're given secant of theta is negative 8 over 7. So, well, before we use that though, what is this angle right here that I just labeled? What is that angle? That's the reference angle for theta, right? That's the reference angle for the angle theta. Okay, so let's call this alpha. Okay, again, we can call it whatever we want besides theta, but let's just call it alpha. Because we like using Greek letters for angles, I guess. So let's zoom back out just a bit. So now what can we say about the sine of alpha? Or sorry, the secant of alpha, the secant of alpha. Secant of alpha equals 8 over 7. Okay, why? Because because secant of theta equals negative 8 over 7, and alpha is the reference angle for theta. Okay, so that's how reference angles and their angles, their corresponding angles work. Okay, they have the trig functions at them are the same value, except the one at the actual angle might be negative. Okay, in this case, the secant of theta was given to us, so it's given as negative 8 over 7. So that means the secant at the reference angle alpha is positive 8 over 7, because that's just how reference angles work. Okay, the secant of alpha is positive 8 over 7 because the secant of theta is negative 8 over 7, and alpha is the reference angle for theta. Okay, so we're kind of using that concept of how reference angles work in relation to their angles, but we're sort of using it in like the reverse context as to how we used it when we just talked about reference angles in earlier videos. But anyway, and also remember, reference angles are acute, right? And trig functions of acute angles are always positive, so keep that in mind too. Okay, this is just an acute angle, right? So it is positive because it's opening counterclockwise, so it is positive. Okay, so so it's acute. So it's inside of a right triangle here. It's acute. It's between 0 degrees and 90 degrees, or 0 radians and pi over 2 radians. But anyway, secant of alpha has to be positive because alpha is a reference angle. Reference angles are acute. Trig functions of acute angles are positive. Okay. So anyway, so one more time, secant of alpha is positive 8 over 7 because secant of theta is negative 8 over 7, and alpha is the reference angle for theta. Okay. How does that help us? Well, it's going to help us fill in this triangle. How's that? Well, remember secant, so secant of alpha, if we come off to the side here, secant of alpha equals 8 over 7. And what's the secant of an angle? If we're talking about right triangles, remember secant is the hypotenuse over the adjacent. Okay? Well, what if you can't remember that? Well, just remember secant is the reciprocal of cosine. Okay, so you can say, okay, well, cosine of alpha, I know stuff about that. Cosine is the reciprocal of that, so cosine of alpha is 7 over 8, and I know that that's adjacent over hypotenuse. Okay. So if you don't like thinking about secants, you just remember cosine and secant are reciprocals. So if secant is 8 over 7, then cosine of alpha is 7 over 8, and I know cosine is adjacent over hypotenuse. Okay, so you could totally think of it like that too. But either way, what we can say is okay, hypotenuse, that's going to be 8. Okay, hypotenuse is 8, and adjacent is 7. Adjacent is 7. Okay, so the hypotenuse is going to be 8, and the adjacent side is 7. Okay, so the hypotenuse of this right triangle is 8. The adjacent side, the side adjacent to angle alpha, is 7. Okay, and then what we need is this guy here. We got to have the length of this side, so let's call that y. Okay, so we're going to figure that out. Okay, so really, it's just like example 2 now. It's really just like example 2. So we just have to remember how reference angles work, remember stuff about right triangle trig, things like that. That's really the sort of trick there. Okay, so now Pythagorean theorem to find this. So it's going to be 7 squared plus y squared equals 8 squared. Okay, so this is 49 plus y squared equals 64. Y squared equals 64 minus 49 is 15. So take a square root of both sides. So y equals, yeah, there's a positive and a negative root, but it's the length of a side of a triangle, so we really should say positive root 15. Okay. Okay, so y is positive square root of 15. So let's write that over here. Okay, now we're ready to go, right? We're ready to get these trig functions here. So now what we could say, now we come over here, and we have to remember reference angles again. So remember how angles and reference angles work. The values of the trig functions are the same, except, so cosine of theta equals cosine of alpha, because alpha is the reference angle for theta, except we might have a minus sign in front here. Okay, why might we have a minus sign? Well, in this case we do, because cosine of theta is negative. Okay, since cosine of theta is negative, we have to have this minus sign out in front of this. Okay, we have to have that there, have to have that minus sign there, because cosine of theta is negative. Why is cosine of theta negative? Because theta is in quadrant 3. Okay, okay. So we know cosine of theta is negative cosine of alpha. That's just a thing with reference angles. Okay, but what is cosine of alpha? Well, actually, cosine of alpha, so we didn't even have to go through all this. We could have just said, well, hey, secant of theta is negative 8 over 7. So cosine of theta is just the reciprocal, which is negative 7 over 8. Okay? So we could have just as easily said that. But if we didn't think about that, like I apparently just didn't, then what we could we just go back to the triangle and say, well, hey, cosine of alpha is adjacent over hypotenuse. 7 over 8. Cosine of alpha is 7 over 8. I know I got a minus sign slapped in front of it because cosine of theta has to be negative. Okay? So this, I guess it's good to see it that way too. So there's two different ways we can get the cosine of theta, okay, but we see it's the same answer either way. So it's either just the reciprocal of secant, so we get negative 7 over 8, or we could use the triangle we just made, okay, and we'll get the same thing. Cosine of alpha is 7 over 8, slap a minus sign in front because cosine of theta has to be negative because theta is in quadrant 3. Okay, now what about the sine of theta? So remember, sine of theta is the same thing as sine of alpha, because that's how reference angles work. Alpha is the reference angle for theta, except sine of theta has to be negative, so we slap on a minus sign here. Okay? What is the sine of alpha? Sine of alpha is opposites over hypotenuse. Opposites, root 15, over hypotenuse, 8. So this is, okay, minus sign still there. Then we have root 15 over 8. Okay, so the sine of alpha is the square root of 15, okay, and then divided by 8. Okay. All right, how about the tangent of theta? So the tangent of theta, we could do sine divided by cosine, but let's not do that. Let's say, okay, tangent of theta, remember that's the same thing as tangent of alpha, okay? But we might have a minus sign in front of here, do we? No, we don't, because tangent of theta is greater than 0. Tangent of theta is positive, because theta is in quadrant 3. Okay, and if we're in quadrant 3, the tangent is positive. So since tangent of theta is positive, then tangent of theta just equals tangent of alpha, no minus sign out in front. Okay, remember these two guys had minus signs. Let's zoom out a bit. These two guys had minus signs because cosine and sine are negative in quadrant 3, but tangent of theta is positive in quadrant 3, so there's no minus sign out in front of here. Okay, so what is the tangent of alpha? It's opposite over adjacent. Opposite, root 15, over adjacent, 7. So this is just root 15 over 7. Okay, that's great. Now for the other two, cosecant and cotangent, we could use the triangle if we wanted to, but we don't really want to do that. So let's just say, okay, cosecant is the reciprocal of the sine, and I know the sine is negative root 15 over 8. So cosecant is just going to be the reciprocal, which is negative 8 over root 15. And again, if you saw some of my earlier videos, you'll know what's coming next. I think that's a perfectly acceptable answer. If you're one of my students, that's totally fine. But if you insist on rationalizing the denominator, if you have to for whatever reason, you multiply by root 15 over root 15, and then you get negative 8 root 15 divided by 15. Okay, so root 15 just gives you 15, but I don't believe that that's more simplified than just negative 8 over root 15. Okay. Anyway, how about the cotangent? The cotangent is the reciprocal of the tangent. Okay, tangent is root 15 over 7. Oh, sorry. That's not what I meant to write. Sorry. The tangent is root 15 over 7. So the cotangent is the reciprocal of that. So the cotangent is 7 divided by root 15. Okay? And again, that's a perfectly acceptable answer if you're one of my students, but if you have to rationalize or if you insist really hard on doing it, then you multiply by root 15 over root 15, and you get 7 root 15 over 15. Okay, so anyway, that's example 3 with using reference triangles to evaluate trig functions. Okay. So here's our answers here again, and here was our original problem. So that's example 3 with reference triangles. Example 4 coming up next.